A warm welcome from my side to the afternoon plenary session. My name is Hannes Mollenhauer. I'm from the Helmholtz Center for Environmental Research in Germany. And I'm also leading the work package 3 in the Credible project, which is dealing with how to monitor carbon farming. And in this afternoon session, we want to discuss technological approaches, but also ways to engage users into a European MRV system. The session will be split in two parts. The first one, we will get a keynote about like half an hour as an input for then a panel discussion, which is following after with all the people you see right now on the pictures. Now, can you switch the slide? We also will have this Menti possibility to raise questions in the Mentimeter. So here you get the code again, you can scan it, or you use the number to type it directly into the Menti app. Since our topic for this Carbon Farming Summit is from theory to practice, our keynote is somehow also designed from theory to practice. So we will start with the Tessa van der Voort from the Nutrient Management Institute in Wageningen. She will give us more like a scientific view of how a European MRV system could be designed. And after that, we get the more real-life example from Marcos Alvez from Agreena. And he will show us an example how they solved this in their company. So warm welcome first to Tessa.
Thank you, Hannes. Thank you all for being here. Take a seat. Yeah? No worries. Actually, could I just have a microphone? Yeah? Does it work? Yeah? Okay. Thanks. I like to move. This is the Netherlands. Beautiful. Water and biodiverse. And cows in the background.
I would just, Tristano asked me to give a quick recap again because so many people are just coming in. So, second round, a bit shorter. Now the people are coming in. Thanks for joining the plenary session in the afternoon. As I told already, this session will be split in a keynote for half an hour, and after that we will have a plenary session with some expert out of the MRV technology, let's say, area. And the opening will do Tessa van der Voort from the Nutrient Management Institute in Wageningen. She will give us a more academic, scientific example how a European MRV system should be designed. And after that, Marcos Alvez from Agreena will give us a real-life example of such a MRV system. So, again, warm welcome, Tessa.
Thank you so much, Hannes. Dankeschön. So good afternoon, everyone. I'm so happy you all turned out still in the late afternoon. We started today by exploring how we should shape a European MRV system and how it can be functional and scalable and usable. And I also heard the phrase, let's use what we have learned from the private offsetting initiatives and apply them. And that's what we are going to do today, as Hannes said. So first, with the scientific part. So MRV is short for monitoring, reporting, and verification, as you all know. And over the last few years, I have worked on all these different elements. So I started my career, as some of you in the room might remember, gathering measurements on long-term sites, hammering down soil cores and measuring every single sample in the lab. And this is crucial. This is the data we all rely on. I've also co-developed carbon offsetting protocols with Vera, which is one of the leading organizations, VM42 and VMD53. And I've also evaluated projects, which you can imagine like a paper review on steroids. Imagine a paper reviewer, and the researcher is not going to be upset with you, but the company is definitely going to have to be checked very, very thoroughly. So I've worked on the M, the R, and the V in both the research capacity as well as in the private industry over the last few years. So I'm going to talk about the things I learned, the things we can all take from that, and then Marcos and Roberta for questions are going to really showcase you how they scaled this approach up in Europe. So why is it important? And this goes for our implementation, but any environmental crediting system. So it's important that it's transparent, accurate. It contributes to our climate goals. Having, and it was also mentioned earlier, having it robust is crucial for investment because companies are otherwise not going to want to buy these credits. It has to be scalable and also be easy on the farmer. So where are we now? So we have heard that at the end of this year, there's going to be MRV protocols for Europe. But what we have seen also from the offsetting market, the voluntary offsetting market, is that there are major data gaps. And these major data gaps are making it hard for us to scale up carbon farming in Europe and also outside of Europe. The first one is the carbon saturation index. So the second, permanence, not all carbon is equal. And the third is to decide which path forward is the best. So let's dig into those in details. So a soil cannot absorb carbon endlessly. Johan Six published very nice papers on this. There is such a thing as soil carbon saturation. Like imagine you going to a museum and looking at paintings. After 2 hours, your brain is just saturated and you need to go somewhere else. So it's the same for soils. They cannot absorb carbon endlessly. The potential to absorb carbon is based on the soil type and the historic depletion. So if your soil has lost a lot of carbon, it has the potential to gain carbon again. But this amount, like how much can you gain, is mostly unknown. So we have some researchers in our team, Sven Verwij and Gerard Ros, who have actually done this for the Netherlands, where we have looked, because there we do have good data, what is the current carbon saturation index and how much can we gain? And we actually found that if you do everything, if you change every button, so you optimize land use, you optimize the groundwater table, and you optimize the pH, then you can really do something. But knowing where you are and how much more you can gain is crucial. And that informs everything. Then, a second data gap is permanence. Not all carbon is equal. Those who have done density fractionation and radiocarbon will know this very well. You can just see an example here from a temperate soil where you see the radiocarbon ages, which are a proxy for how old the carbon is, vary very strongly between the labile, the non-labile, and the mineral-associated fraction. So we know this, but we only have data like this for very few sites, and it's very difficult to scale it up to more areas. So the question is, for the remaining carbon in the soil, how stable is it? Or the carbon that you're adding to the soil, how long is it actually going to stay there? That is a major data gap we need to solve. Then the last one, the best path forward. What is the best path forward, and how much will it bring me? So even if I know my soil today, how do I know which action is the best action for me to take to add more carbon permanently to my soil. So can you identify an optimal scenario? You can, of course, use models such as Rothsea and Dayscent, but still it is very tricky. And to my knowledge, we don't have maps for this, like this for Europe. Again, work from my colleagues who have looked at the Netherlands, at things they could do to increase the soil carbon. And the secret is, for the Netherlands, make everything permanent grassland. And the thing is that I also do scope 3 projects for large landowners. And if you make everything grassland, yeah, sure, you'll store more soil carbon, but your net emissions will definitely be higher because you'll have a lot more cows. So having these different options, like more biogenic inputs, more green, more carbon, tillage. The effect of tillage is very poorly known. There was a very nice paper by Hyun and Yo recently published with tillage rate modifiers, but still there is a lot of uncertainty what the long-term impacts of stopping tillage are. Fertilizer change, more organic fertilizers. Again, there's the questions of permanence, and for grasslands, we also don't know how long-term the effects are. So then, reporting, don't look at all the details. This is an overview of the protocols that already exist. So I think we can learn from them. It's a very nice paper by Emily Oldfield. And all these programs have different requirements, and all these programs have different trust levels. But it boils down to this. So what I've seen, I've worked on different protocols. So you have the possibility to have an easy way, a low complexity where you just have remote sensing, legacy data, or you get increasingly robust by adding models, by adding data, until you get to a very high complexity and a high robustness, but then your cost is very, very high. So a question for discussion is, how do we consider this when scaling up? Do we do it quick and dirty or not? So there are also, for verification, major hurdles. So remote sensing can be leveraged to see, for instance, if people are using cover crops. But often you still need proximal measurements, and those, again, are very costly. And there needs to be enough left over for a reward for the farmer. And right now, at least in the Netherlands, we see that this is a deal breaker. This left side of the equation is too expensive to enable the right side. So then, what does our destination look like? Well, we need to weigh different elements, also for the co-benefits. So you have costs of measurements and the process to attain approval. This is going to take time, energy, and effort. And also the cost of additionality for the farmer, of getting cover crops, of putting in that extra time. And then you have the other side, financial reward for the farmer, and also co-benefits for other ecosystem services, such as biodiversity. So just to show this again visually, when we look at co-benefits, we should also be realistic, and it's not always that the sun is shining. There can be positive sides of carbon farming, but there's also risks. We've heard a lot about the co-benefits already today, but we also have to acknowledge that there are losses potentially happening, such as a reduced yield and a higher risk for pathogens. And if we don't consider those for farmers, then we cannot convince them to implement practices. So to wrap up before I go to Marcos, so what I've seen so far in the offsetting market as a scientist is that you need very strong expertise in soil sampling, in lab methods, modeling, and verification procedures. You literally do need a PhD in soil science, and that doesn't work, right? Ideally, we want to have plug-and-play measurements, which are accessible to any farmer. Like I work now, as I was saying to Hannes, with the sons and daughters of farmers who we are trying to give methods so they can measure carbon in their own farms, automated data prep, and no labs needed. So then, my outlook would be that in an ideal world, we would have an automated data pipeline for the entirety of Europe, where we can see what is our carbon saturation index today? Like how much do we have, how much can we gain? And then also to see which path is my best path forward, which measures should I take? Then having protocols that are aligned to that, and automatic verification and rewarding for farmers to actually make it worth their while. And with that, we have covered the M and the R and the V. And now I would like to give over the floor to Marcus, who will give an example of MRV in Europe with Agreena.
Okay, good afternoon, everyone. First of all, thank you very much, the organizers, for the opportunity to talk, and Tessa for inviting us to share this keynote with her. My name is Marcus. I'm a modeling lead in Agreena, and the team that I'm part of is responsible for the calculations that I use as a basis for the carbon credit generation in our project. And today, like Tessa said, I just want to share with you a little bit of our approach on how we calculate soil organic carbon change. That will be the basis for part of the carbon credit that we generate in Agreena. Before we start, I just would like to share with you a little bit about Agreena. Agreena is a European company that's based in Copenhagen, but that has activities in 20 countries in Europe. We are working together with 2,300 farmers already that cover an area of 4.5 million hectares, which is roughly the size of Denmark in Europe. And we are the first large-scale project of arable land that has been registered in their VCS schemes. So we are actually developing a lot of the pipeline that Tessa mentioned to achieve those results. And when Agreena started, we knew we wanted to be ambitious, we wanted to have this big impact, and we knew that one of the most important things was to follow a robust guideline or a robust methodology for estimating the soil organic carbon changes. And that's why we looked at Vera, one of the most important standard setters. And we found this methodology, VM0042, which is used to estimate the impact, used to generate credits based on the land management improvements. And within this methodology, or within this guideline, we have two methodologies that we can use to estimate soil organic carbon change. One methodology is called measure and model, and the other one is called measure and remeasure. Both of them addresses the most important aspects of soil organic carbon estimations, which is the local sensitivity of soil organic carbon to, for example, the soil type, climate, and the management history of that field. But there is a very important difference between the two that may be the reason for which programs or projects like ours will choose one over the other. In our case, we chose measure and model because it's a way of dynamically following up what's happening in the soil over the years. With the measure and remeasure, we have to wait a couple of years before you are able to issue credits. And with the measure and model, we can dynamically follow the soil organic carbon changes and hopefully issue credits on a shorter period, which is very important for us as project developers for reasons of cash flow. But when we choose measure and model, we are obliged to follow a couple of requirements. We need to be able to comply with a couple of requirements. And those are the things I want to share with you, how we are complying with those requirements to be able to issue credits reliably following this methodology. The first requirement is really written in the name of the approach, measure and model. So the measure part, what we have to measure? We have to measure soil characteristics. And which characteristics? Bulk density, soil texture, but especially soil organic carbon. And this value, the objective of measuring soil organic carbon in the beginning of the project is really to set up a baseline, a basis for which we're going to start our second part of this approach with the modeling, but also serves as a comparison for the future. When we have the project running for a couple of years, we can look back and see and do another remeasurement and compare the results and see how we are actually doing in comparison to our forecasts with our modeling. In Agreena, we have like hundreds of thousands of fields that we need to monitor. So in order to sample all those fields, we developed an algorithm that I'm not going to go into the details here, but we can talk after the presentation about it, that clustered the fields or the project instances into homogeneous groups. And then from those homogeneous groups, we select samples that are going to be, we select fields that are going to be sampled for soil carbon. And that covers the first, let's say, part of this methodology. Once we have our soil sample, the next step is really to select a model. And the objective of selecting a model is then for you to have a tool for monitoring these dynamic changes in soil organic carbon. In Agreena, we selected ROTC as our model. It's a really very widely known model, a reference model for long-term dynamics in agricultural soils, and has been used for hundreds of scientific publications, from FAO estimations of soil organic carbon potential across the world, other projects, other methodologies. So it's a really, really widely known model. It is very transparent. There is no gray or black box around ROTC. What it does is very easy for people to understand. And it's flexible enough for us to model the changes that we want to promote in our project area. So, namely, these three practices: tillage regime changes, cover crop application, and organic amendments applications that could be either use of organic fertilizers or mulching of residues. Next, it's not enough to select a model that's widely known, widely used. You still need to demonstrate that you are able to use your model confidently in your project area, and that your model, I mean, not only you are capable of using your model confidently, but your model is also fit for the area that you want to apply it. Because, as we said, soil organic carbon is very locally sensitive. So we need to be able to prove that our model can work for the crops that we are modeling, for the climate zones where we want to operate, and for the practice changes that we want to promote. So when you multiply all these factors, you get a huge amount of combinations that you need to prove that your model can work. And how we do this? This process is done by us going out, collecting real-world data from experiments, using this data to run our model with, and then comparing the results of our simulations with the actual results of the studies. Through this comparison, we are able to tweak the model in order to make our simulations as close as possible to the actual results of the studies. And then after we do these adjustments, we build a report called MVR, Model Validation Report, that we have to submit to the assessment of an independent modeling expert to check that the work that we've done is really good, and we are then able to use the model in our project area. Only after the IME sign off on our model calibration, on model validation report, we are then allowed to use the model in the project area. And this is what we already have done in Agreena. Okay. So now we have soil sample, we have selected a model, we have calibrated, we have demonstrated that we know and that we can use our model in the project area. Now we need to collect a lot of data, which is like a little bit of what Tessa was saying about the pipeline. We had to build this huge pipeline to collect data for 4.5 million hectares and 2,300 farmers. And I cannot just show you all the data that we collect, it's a lot, but I could group them into 4 different types of data that we collect. One is farm attestation, so what the farmers tells us directly about what they did before they joined the program and what they are doing after they joined the program. Then the other group of data is like the peer review and publicly available scientific data. So data that the farmers cannot themselves provide to us, for example, climate information, precipitation, evapotranspiration, temperature. that we need to run the model, the farmers cannot provide, so we have to get it from scientific resources. And the other group, satellite-derived verification data powered by machine learning algorithms that we have developed in Agreena to verify the data that the farmers report to us. So we cannot just trust what the farmers are reporting. We need to check that, so we generate huge data sets of verification data to compare with the reported data sets the farmers are telling us. And finally, regional statistics that are also used for checking the reported data from the farmers, but also help us to complete or fill in gaps that we might find in the data sets that we are collecting. So once you have all of these in place, you have your model, you have your soil sample, you have your calibration and validation model report approved, you have your data set, you have your pipeline set, then you can start running what we call scenarios. In the context of VM42, we need to compare two scenarios. We need to compare a scenario called baseline, which is really a hypothetical scenario where we assume that the farmers that joined the program would continue doing whatever they were doing before they joined the program over the crediting period. So we assume that they didn't change their management practice. This is our baseline scenario. Then we have a project scenario, which is what we are able to verify, or the practices that the farmers tell us that they are implementing and that we are able to verify. So we run our model again using this improved management practice that they reported and that we were able to verify. At the end, we compare the two, the project scenario, the baseline, and the difference between the project and the baseline is what we call soil organic carbon changes. And in the context of VM42, this is called carbon removals. But the carbon removals, when you get your carbon removal, that's not the end of the story, because there is still risks associated with that number, your estimated carbon removal. And to address this, we have actually three types of groups of risks that we need to address according to VM42. One is the risk that our calculations, even though we can have the best model, the best calibration, whatever best data, even though we do that, we are using a model, and a model is just a representation of what's actually happening in the world. And we can measure how well we are doing these estimates. This is what we call model uncertainty, and this model uncertainty is used to calculate a deduction that will be subtracted from the soil organic carbon changes that we estimated, in order for us to make sure that if we are not spot on, we are at least underestimating, not overestimating emissions. So this is a deduction designed to prevent that we overestimate. The second risk that we have to address is the leakage risk, which is a risk that by storing carbon or by changing practices and storing carbon in their fields, the farmers are promoting emissions somewhere else for several reasons. So we need to estimate how much that is and also subtract that value from the soil organic carbon. And finally, we have a permanence risk. So something might happen that the farmer leaves the program, or there is an extreme weather event that make all the gains that the farmers were able to accrue to be lost. And we need to address that. We calculate how much that risk is, and we also subtract that from the soil organic carbon changes. So at the end, the value, the estimation of soil organic carbon that goes into the generation of credits is really a fraction of what we estimated. And just to finish my presentation, I would like to say that the soil organic carbon estimation is really a part of the process of generating carbon credits. There is also another branch that deals with the emission reductions, which unfortunately because of time we're not going to be able to cover here, but we're going to be here throughout the conference, and if you want to know more, you can just reach out to us as well. So that's all I wanted to present. Thank you very much, and looking forward to the questions.
Test, yeah. Thank you, Marcus. Thank you, Tessa. We have now time for one or two questions for the keynote, because later on just Tessa will join the panel discussion. So if there are any questions, just raise your hand. I will go around with the microphone, or you will do it. perfectly.
Thank you very much for your presentation. And the question is about the model ROTC that you mentioned. How do you deal with initialization of the model? I mean, how do you calculate the equilibrium? Because the model, this is a very important part of modeling, and uncertainty in there is very, very important.
Yeah, so actually, this is a very good point. I didn't put it on my presentation, but to initialize the model, we do an optimization process. So we have a measurement, and we have one carbon pool, right? And the ROTC has 5 carbon pools. So we created an algorithm that optimizes the 5 carbon pools in respect to the measurement. So at the end, the sum of those 5 carbon pools are equal to the measurement. And we do that by simulating the equilibrium and varying the biomass inputs of the model. So we vary the biomass inputs, simulate 10,000 years of equilibrium, and then when we reach the same amount of carbon in the 5 carbon pools in the ROTC compared to our measurement, then we stop the optimization. So that's how we initialize the model. Yeah.
There's one in the back. One question.
Hello, thank you. My question goes to the climate data that you need for the model. So when you have your prediction of the future with the baseline and the whatever project, which climate data do you underlie in your modeling?
Yeah, currently we are using NASA power data, climate, temperature, evapotranspiration, and precipitation. We make a climate normal of the last 30 years. We collect the last 30 years of data from that specific field. We calculate an average, and this is the data that we use to run the model with.
Okay, thank you.
Yeah.
Hello, my name is Rico Hubner from German Agroforestry Association. Question for Marcos. I would be interested in the baseline assumption because we did a calculation back in 2016 where we found a between 12 and 16% decrease in soil organic carbon in a climate scenario of plus 3.3 degrees. Now, I mean, that was 2016. Now we already have probably 2.5 or more. So I wonder how you incorporate the next 10, 20 years of climate and what would be your results of the baseline scenario if you wouldn't do anything today. Thank you.
Yeah, also a very interesting question as well. So in terms of climate, like I said, we use a climate normal. So we look at the past. We don't look at the future to do the simulations. And this climate normal in our methodology will be updated annually from actual data. So we will be able to capture climate change as it happens because we do annually simulations. We make a prediction forward 20 years, which is the crediting period, but we issue credits on an annual basis. So we will be able to capture climate change as it happens with this methodology, we hope.
There's also the aspect that was mentioned on the last slide about buffer and risk. So that looks more at like future scenarios. What is the likelihood of climate impacts, political risks, all other aspects of risk that may be natural or human created. And then they also take out that slice off of what is the potential or likelihood of that happening in future and how do we ensure that we account for it and not overestimate as well. So that's built in through a non-permanence risk assessment, which derives that figure.
We have time for one last question. Ah, perfect.
Your modeling approach clearly works very well when you have areas of uniform soils. But in Northern Ireland, for example, and over a good deal of Ireland, the soils are extremely variable, literally from meter by meter in places. And we have concluded, I think, that we would need to do the measure and remeasure approach on that. I'd wonder what your thoughts are on the differences between different soil types across Europe, where there may be big areas that have very uniform soils and other areas with very, very variable soils.
Yeah, also a very good point. Thank you for the question. Like I said, modeling soil organic carbon is very sensitive to local conditions, and this is well known. The question there is again, like how precise we have to be in comparison to the ability to run a program at the end, right? Because we could model meter by meter if we want to, but how costly that would be. And this would be definitely not economically viable from my perspective. Although we do model on a relatively small scale, like the data sets that we use to initialize the model are on 250 meters. So it's not really that we are modeling a pixel of 500 kilometers or like 50 kilometers. So it's relatively small. I agree with you that it varies meter by meter, but like modeling meter by meter would be a big challenge, maybe not economically viable.
Yeah, I think the selection of quantification approach as well has been a big factor in, how do we scale change here? And I think that's been a lot of the theme of what we've been talking about so far today in the conference is, we have, of course, a great presentation about the model and the work that's been done. We also recognize there are ways to get better. What else do we need to do? How do we need to be able to address how we reduce uncertainty, improve stratification, and how do we ensure that all of that reinforces and builds to create that change and keep meaningful change consistent? And I think looking at it in terms of lessons of how to run across a very large area, there are always going to be these different scenarios. I think it's going to be very hard to get 100% certainty, but what are the mitigations or what are the different activities that you put in place to be able to manage that level of uncertainty that happens over such a large area?
I see, Maria, you have a question, really the last one, because we have to continue our schedule.
I don't think, yes, okay. A question to Roberta. You spoke about the saturation, that's good, it's important, but I think that this saturation, it is, it's for you, it is not stable, because in climate change scenario, you will not have the same saturation level. You will have, for example, less potential to store due to climate change. So I think that also the temporal scale should be considered.
Oh yeah, that's a good point. I absolutely agree. The saturation index could change if the temperature changes. However, based on soil type and historic depletion, we should at least get started. And then, as Roberta also said, then we can start incorporating that in the future. Yeah. Thank you.
Okay, then thank you again for the keynote speakers. Let's continue with our panel discussion, and hopefully, we will have a fruitful discussion afterwards, maybe with the guys from Agreena. Thank you again.
Thank you.
So maybe when the panelists are now coming up to the stage, I would ask again for the Menti code, that if somebody still needs to add the code to the app, you can now check it out and raise some questions in the app. Yeah, I think we should take the seats with this microphones here. Yeah. Does anybody has one? Yeah. I think anybody is able to get to the mic. Yeah, it works perfect. All right. Before we start, we saw already some pictures and some names, but we discussed in advance that we make like a brief introduction by themselves. So maybe we start at Véronique's side. Please introduce yourself, and then we're going through.
Hello, everybody. I'm Véronique Chauvin. I'm an environmental manager in Chamber of Agriculture in Pays de la Loire in France.
Hello, I am Edouard Lanckriet. I work at Agrosolutions, which is an engineering consultancy specialized in agricultural transition. We are owned by the biggest farmer union in France, which is called In Vivo, and we participated in the label Bas Carbone. We drafted different methodologies, developed an MRV digital tool, and now we're participating in the MRV project in the CRCF. Thank you.
Thank you. My name is Toonen. I'm from Space for Good, and Space for Good is a social enterprise that uses remote sensing for mostly vegetation monitoring. So we're also here mostly focused on above-ground biomass carbon estimations with the use of remote sensing technologies.
Good. My name is Tessa. You already saw my keynote, so I'm going to skip right to Greet.
Hello. I'm Greet Ruisgaard. I'm from Belgium. I work at ILVO, which is an agricultural research institute, and I'm currently the coordinator of the MARVIC project, which is a soil mission project on MRV.
Hello, I'm Ahmad Bitar. I am from CNRS, France. I work on developing MRV tools. I'm head of development of Agrosolutions for carbon farming, and what we like to do is combine high-resolution data to make estimate at 10-meter resolution, but at country scale for 9 million pixels, 9 million plots, for example.
Okay, thanks a lot for the introduction. I want to start with some questions to Greet. Since December, we have a regulation we can work with, also in the EU projects, as you mentioned, like MARIC. And we got a vision from Tessa how an MRV system in Europe should look like. We got also the real-life example from Agreena. Do you see the same challenges what Tessa highlighted? Do you want to add something? Do you want to comment something on these challenges which were shown recently?
Yeah, I guess we all agree that there are many challenges ahead. One of the challenges I see is that to make a robust but also cost-efficient MRV system, we actually need to combine many things. So we need soil scientists, soil sampling, modeling, integration of earth observation, but also integration of data. So that makes cooperation between different disciplines, and that's quite challenging. I also heard Christian, the wish is that this morning, so that the wish is that this MRV systems for carbon farming would be similar to the systems that we use for greenhouse gas inventories, for CAP, also for the soil monitoring law, so there is some synergy. So I think there is a great challenge there to work together also with the regions and the countries, so that we have a system that's modular and that builds on each other, actually. So that also makes the challenge of the cooperation between the national and the regional and the European level. And also, of course, last but not least, the challenge of the cooperation between public and private actors. And so the question is, there needs to be a lot of trust between all these actors to have a win-win situation between all of them. And secondly, the aspect of fair data, like obviously many data are produced both at the public and the private sector. So how to make them fair and to make them useful for further elaborating our MRV systems. And then thirdly, I would like to highlight, so actually we are talking about certificates, and certificates, it was also nicely shown in the presentation of Agreena. So we need to model actually what a land manager is doing and how much carbon is stored, or how much the evolution is in carbon in the soil. But we always have to deduct it from the baseline, and that's a big challenge, I think, because we do not only need to know the uncertainty of what we measure or monitoring at the farm, but we also need to know what is the uncertainty of the baseline we are, and we should really not forget that if we want to have a say on the uncertainty of the ultimate carbon farming certificates. All right.
Okay, thank you very much. I want to stay a bit on this topic, like data gaps and harmonization you mentioned. Maybe I will look in this corner to Edouard and Véronique, since you're also co-developing the French label, the low carbon label. Maybe you can give us some insight, like how do you manage in this scheme, like topics like how to harmonize data, how to overcome gaps for critical data you needed.
Okay, well, long story short, Label Bas Carbone is a collective approach and a public approach. It's very important because so it gathered soil scientists, mainly from INRAE, model developers, also from INRAE, technicals that works with the farmers from Arvalis, for example, and representative of farmers and farmer cooperatives that we are. And all together, we wanted to design a carbon certification scheme that would be both reliable, trustable, but not too expensive, very easy to use and to access for farmers and farmer cooperatives, but also agro-food company. So we decided to build something upon a public soil model, which is AMG. The use, I mean, AMG is validated and calibrated by INRAE and French scientific teams, so it's cheap. It's not cheap, but it's publicly financed, and the robustness is guaranteed by our public science. And then, but I mean, to use the model, you need to have an end user tool, and this relies on the private actors that can code, design end user tools that automates AMG. And we developed such a tool, which is called Carbon Extract, but we're not the only one. There are maybe 5 different tools, MRV tools in France that run AMG. And then to cope with the issue of data collection, whenever we take a farm transitioning into a carbon farming program, we collect up to 8,000 data per farm to draw the baseline, to draw the project line, to do the verification, everything. So second step was to automate data collection to FMIS system and to meteorological databases also. And it helps, so we have quite a reliable and not that much expensive MRV device, but we still face a lot of challenges. You mentioned the cost of the programs. It's still very costly for farmers, and we lack of a robust and scalable economic model to scale it up. And maybe last point is that we took more than 1,500 farms into our programs, but to do so, we did not do it by ourselves, and we relied on the networks of technical advisors all around France. They're part of agricultural cooperatives or chamber of agriculture, so we designed a specific program to train them to use properly the MRV tools, because you have an MRV tool that runs a certificated model, that's okay, but the way you use it can impact a lot on the results. And maybe this is a black spot of certification schemes. Who use the MRV tools, with which process, in which way? So we designed those teaching programs. It's 2.5 days for each actors willing to work with the farmers. We train them, and then they can use the tool and take the farmers transitioning. And I think I could talk for hours, but I will leave the room for my colleague.
I did it with my experience in the Chamber of Agriculture in Pays de la Loire in Brittany. We took part in the development of low carbon labeling management linked to the sustainable management in the bocage. And this method has been validated and recognized by throughout France by the government. This makes that all technical operators can, based on this reference, to advise farmers and to make the plan. In fact, the method is based on the tool, the sustainable grow management plan, and a method to calculate it, the carbon store in the various compartments of the trees. Remuneration of carbon credit, it's things between the advisors, farmers, and companies. We work with companies to have private remuneration. This payment is payment for environmental services. It is based on additional storage in the result of the sustainable management and the good farming practices implemented. In this way, you talk about the monitoring. What is important is to have a field visit with an advisor to can judge if the plan is respected, and if it's okay, we can continue. But it is not okay. It's important to explain why, to have a processing, a training, to have a progressive activity on the farm.
Maybe one last word regarding the MRV tools. At first, we designed them for the MRV of carbon farming programs all around crop rotation, but the market is driven for the moment by Scope 3 claims. So agro-food companies and farmer cooperatives ask us to design now the same MRV tool to be able to claim, to calculate both at crop level and at the scale of a crop rotation. So we are, with the Label Bas Carbone team, we are developing other methodologies, notably allocation rules for carbon removals, to be able to say what is within Scope 3 and what is outside Scope 3. It's the next step.
Yeah. Okay, thank you for the insights. I think this is really important, what you mentioned also about the Scope 3 indicators. My next question would be going to Liv. Since you're here as a Space for Good representative, but also like a representative of the European Association of Remote Sensing Companies. So one crucial point is also the above biomass estimation. And I think this is something you could talk about, like how can we use remote sensing products or remote sensing data to capture this part of the model, and also like the point of the data availability of the remote sensing products. This would be interesting because I think we always talk about European data products, but is it really the truth that we have such products?
Yes, we do have such products. No, so that's great news. Yeah, so indeed, when speaking about also data gaps, what we often see is that there's still a lot of data gaps spatially, because when you do a field measurement, it's in a certain location, but also temporally, because you cannot go into the field and do measurements every year. And this is actually something that we can do with the use of remote sensing satellites. So from Copernicus, from the European Space Agency, but also from the EU, we have freely available for everybody 10-meter resolution data. I think most of you are by now aware of that. And depending on which country, there are also higher resolution data sources available, or even lighter data sources available. And really leveraging these data sources that are both covering the whole of the European Union, but as well have a very high temporal resolution, so are often have a lot of your regular updates of this data, can give really clear insights in changes of carbon, but also in comparing one area to the other. So this is actually super valuable that we have this available. There's something that I would like to note on that as well. So depending on the application, it really depends on what accuracy or what resolution is necessary. So for example, for more complex systems like agroforestry systems where it's much more variable between crops and trees, maybe we need a higher resolution data source. And in some countries, these are freely available. Like for example, in the Netherlands, we have a 1.2 meter resolution data available, or even lower when it's adjusted. But and also LiDAR data available, which makes us actually getting a lot of insights on the vegetation in the Netherlands. But this is very unfair if you compare it with other countries, because other countries, they don't have this freely available data. So this is actually a challenge that we still need to overcome. We can use the Copernicus data sets, which are very, covering everything and can give a really good basis. But if we want to go more into detail, high-resolution data sources are super valuable with respect to from Earth observation. And this is still not equal within the countries.
Okay, thank you, Liv. Maybe one question to Grete again. You talked about the long-term data uncertainty. Maybe this is also the point we should talk a bit about the long-term monitoring sites which are producing such kind of data. What do you think? What are the crucial points when we are looking at the long-term monitoring networks? What is it? The representativeness, or what do you think? What are the major issues?
Yeah, I think good long-term data are absolutely necessary, and to have good time series in long-term field experiments, but also time series of monitoring networks on farm, for instance, where we not only collect in detail soil data, but also management data and also biomass data, for instance. So that is really crucial, not only to calibrate or validate the model up front before we start a carbon farming scheme, but I think these monitoring networks, I would suggest we also, if you have a good network across Europe, it could be used actually to verify over time also all these monitoring systems and models that are being used as a kind of ring trial maybe. So it's also a plea maybe also for the public sector, both at European but also the national levels, to invest really in these monitoring networks and the very good data they should produce, because I think they're absolutely necessary.
So the essence is support your local monitoring site, yeah? Yes. A question to Ahmad. We heard a lot of now from data sources and also about methodologies. What do you think when we're talking about how to harmonize these different kind of methodologies? What do you think are the crucial points?
Yes, this is a very essential point in terms of MRV. Think about a company like doing insetting in France, but this is a big agro company and has sites across the world. What does it mean that they run a scheme in France quite different than the one they run there? I don't consider that harmonization is uniformization, but we should understand that there should be efforts to harmonize the approaches in terms of quantification for carbon farming, so that we can actually compare these and try to advance. And also harmonization enables us to define components, and once we have these components into the scheme, then we can actually build upon enhancing. And there I want to point out some aspects. And before this, I would just say that we're working intensively on harmonization, and tomorrow I will be presenting some of these aspects on the latest work from Organiser project, where we made a report on cookbook and on harmonized MRV that is available today, and just this week it will be available and it's a deliverable of the project. So let me just point out some aspects about the harmonization. Once you harmonize the approaches, then you can compare them. Also, you can make decisions on decision trees where you want to choose which methodology, which is applicable. One thing that's weird today, we heard about the fact that Vera asks for each scheme runner to validate the model. So let's consider someone in Ireland working on the model, and he actually validated it for quite all Ireland. Why would another company need to revalidate it? I had two companies, we work with many companies, Agrosolutions and Plenary companies, we're using AMG model. But then these companies came up to us and told them, we want to test on the ROTC approach, and then we were working on implementing it. And we need to work on the Vera approach, and then they're working on the same region, but they want all of them to validate. I don't understand it. Also, and the essential aspect on this point is that if you think about it, people mix between validation and uncertainty estimate, validation and calibration. Long-term sites are needed for validating, calibrating the models, making sure that they can be accredited. Once they are accredited, then they can run on different areas with verification for the making sure that these results are good, but the person rerunning them, once they are acceptable to run, you don't need to redo it, okay? And one last point I will add, on the effort of adding the data, and we discussed this already, it's very important to consider that the verification is a transparent action, right? It should be transparent.
Should be, yeah.
And it's third party also.
Yes, should be.
Okay, so I suggest that we should ask all the companies making the verification to make the data verification available. This is critical and easy to do. Once you do it, year after year after year, your database is increasing. It's not the long-term sites, it's across different areas. And then GRC can introduce this data in their system. And it's not, zero cost here, and it's a transparency. So this is a suggestion I would like to be added to the conclusions of this workshop, for example.
Okay, thank you very much. I think there are some points you pointed on. It's really important to think about these processes. I see the time is running, so we have to get to another topic, which I think also is the people in the audience are interested in, is about handling costs and also the complexity of such state-of-the-art systems. And since Edouard, you had a workshop or a session in the morning about business models, the potential business models. Maybe you can do it, give us a little wrap-up of what right now is potential ways to finance such a certificate.
Sorry, it was actually my colleague Roxane who held this session, but that's okay. For us, I mean, to sort out this economic model, we need to automate as much as possible all the elements of the MRV. So for the moment, we are working a lot on making connection with satellites data, especially for biomass estimation, but also to provide to the farmer one single tool that calculates all the carbon claims he needs to account for, be it for scope 3 and or for offset, with clear rules for double countings and perimeter allocations. Those are the kind of programs we're working on.
Okay, thank you. And I think reducing costs is also a point everybody is looking on. So, as Tessa showed, this scale from just Sentinel-2 data, I think was on the left side, and then there was getting more complex and complex and complex. Do you think that that's the way to reduce the cost to the clever use of Earth observation, I would say?
Yeah, indeed, exactly what you're saying. It's about clever use of Earth observation. So, of course, we can't go without the field measurements. But as everybody's probably aware, the field measurements are take so much time and manual and are expensive. So combining them with remote sensing technologies and also Earth observation technologies and also machine learning models, we can really cut down on these costs while staying actually really accurate, especially when looking at local models for local areas. This is really, we see that there's still a lot of possibilities there and challenges, chances there to reduce the cost of manual labor in the field. And there's actually another thing that I would like to add on this is that I think it's very important. Now we often see remote sensing as, this is going to be the instead of doing the field measurements, or we're just going to do more remote sensing and less field measurements. But I think it's also very important that we take remote sensing into account in all the other steps as well. So if we understand really how remote sensing works, which is, in my opinion, a technology that has to be used because we want to be scalable, we want to be having this transparency of the measurements. It is very important that also within the verification step, which is currently still very expensive, the understanding of remote sensing needs to be taken into account. So we have to take it into account in all the different steps of how the remote sensing technologies work and how they have to be verified in the best way possible, and also to keep the costs as low as possible, especially for smallholders farmers. If they have to do separate verification, that's really costly. But if we can combine different farmers which are in the same area, for example, which are where the model works well, then maybe we can combine these kind of verifications and costs. Yeah.
So it's good. Do you want to add something, Tessa? You're looking like...
if I may. Thank you. Wow, Hannes, you have a sixth sense. Yeah, so I just want to add to Liv's point. So this cost of measurement is really high and is often a deal breaker. So there's also a kind of a new wave of technologies, proximal sensing, so based on near infrared, mid infrared, or gamma ray. And they have great potential. Tomorrow, Paulina has a session on this in Bedford 1, I think, in the afternoon. So if you're interested in that, please join. And I think these technologies have a lot of potentials. I've seen that these large Scope 3 clients, these massive groups, have already switched to proximal sensing instead of old school wet chemistry.
Yeah, you're totally right. Thank you for saying that. Yeah. And hopefully you can join this session from Paulina. Yep. Now, we talked a bit about cost. Now I wanted to go more to the complexity part of the MRV systems. And I wanted to ask like Gret and Véronique more as a user perspective, I would say, and Gret more out of a academic, scientific, developing perspective. What are the major hurdles for complexity in the systems? What should be easier for the users? What should be like maybe like changed in the developing process, more related to Gret? Do you want to start, Véronique?
Yeah. We observe that for farmers, for users in general, it's important to have simple, reliable, measurable, and reproducible indicators. It's not important to multiply indicators. It's important to answer that the indicators are relevant of the practices implemented. On the grassland and the peatland, for trees and agricultural production units, we also need to include the cost of supports for changing practices and technical monitoring of the action implemented. The importance for farmers will be all the more involved earlier in the process. If they understand the expectation and the various elements of the scheme, it's more easy. And we observe that the system, they are too elitist, are doomed to failure. It's important to work more earlier with farmers in the process to have a good response for their attempt. The issue of agriculture today is to be more resilient of the climate change and to have an economical viability on their action.
Yeah, thank you. Maybe you can share also your perspective, Gret.
Yeah, complexity. I think what is the purpose of complexity? Hopefully not complexity, but I think it should add either to have a more robust system, or hopefully also to make it more easy for the land managers, like to reduce the administrative burden or the costs. So I suggest to work with a kind of modular system, especially if we have this measure model systems. For instance, you could work with fixed values for carbon input to crops, but then along, like if you have a system like Agricarboneo, where you have calibrated your biomass input to the soil based on remote sensing, well, we do not have it all for all crops and in all areas right now, but gradually I think we can add that kind of complexity, so that should be possible actually to do that. And also I think we really should work on making it easier for farmers, so maybe also connect with the CAP system, because there they already have to, maybe a lot of data are gathered and also verified actually at the farm, so how to make the data connections and to automate the data connections actually, so maybe to make a more complex system, but make it easier for the end users.
Yeah, thank you. Thank you.
Well,
Yeah, sure. Go.
So I would like to give an example. Let's take one plot, and this farmer has a plot, and it happens to be that he has a disease. He goes and runs a crop model, like sticks, like WOFOS, or whatever. And he has to parameterize for the disease, right? Because he's running it, and he needs to put a percentage. But he doesn't know how exactly, but he doesn't know also the impact. Would it impact at which level? And say, okay. And then another exercise, you take the model, another model, and you put remote sensing data, okay? And you actually force the model to follow the dynamics of the remote sensing data, without telling the model there was a disease, which percentage, which one is the most complex. Certainly the first one is more complex, because you cannot parameterize it. Do not confuse the fact to add more data to constrain a system as a complexity. This is simplification. This is, you use a simple model with information inside, and then you simplify your approach, because you're using real data of observation. So you're injecting information, real information into the system. So we argue that we should use vegetation observation systematically when it is possible in the MRV approaches, because this is readily available, and this reduces uncertainty, and reduces complexity. We got no need to define, and I mean, if you consider that you will run all the models without never considering disease, extreme weather, and parameterizing them. So this is my idea about it, and we've been explaining this for some time now, and we hope that it's an idea that going pushed into the MRVs.
So as we discussed also before, like there should be a basic workflow which is fixed, and then you can add complexity if you have the data to describe it, for instance, like diseases and so on. Is this the way you want to promote it?
You probably, if your question is this one, you probably don't want to want the complexity on observing the disease, probably, maybe. You want to put it on the, this issue about the carbon pools, on defining the different carbon pools, which is a complex. Today we use simplified, and AMG is very simplified, and ROTC very simplified, because we don't know how to parameterize them also. But maybe in the future, by combining the more observation of multispectral, hyperspectral sensors that are going in, even satellite-based. Also, we've seen AgriCarbon, working on very nice sampling methodologies with spectral information. So maybe we can better parameterize in the future, right? I don't know.
Yeah. Sounds good. We are really running out of time, so there's maybe time for one question to Tessa, and then we will look at the Menti. Saskia, you will send me yeah? No timer for the Menti? Okay, then maybe just the last question to Tessa. Véronique already mentioned like the schemes they run in peatlands, in hedgerows, in grasslands, and also there is this, how can I tell this, not an issue, but we need somehow standardization approaches, and we need, as Ahmad also told, like validated scenarios to run the models in future. And what I think is, what is from your point of view, the challenges of such validated scenarios in a, let's say, classical carbon flux way, but you also mentioned the co-benefits in your presentation, like how do we include such kind of effects, how to standardize them, how to validate them. Yeah.
Thank you, Hannes. I think that's a great question to wrap up with. So there are great benefits to carbon farming. We discussed them, but there's also risks, and we need to also quantify them. For instance, if you re-wet peatland, you will remobilize a lot of organic material, and you can have leaching of phosphate, for instance, which can really be very destructive to your aquatic biodiversity. So we need to consider the positives as well as the negatives, and when it comes to standardization, I fully agree, but I think there's not enough data for that at the moment, based on my knowledge. Yeah.
Okay. Thanks, we are sorry for the audience that there's no time anymore for other questions, but now you know the faces and you can approach them and ask them the whole evening, I guess, or tomorrow. Okay, then thank you again to the panel for the discussion, and hopefully we have a good wrap-up.
It's not finished. We still have a wrap-up session for today, and I would like to welcome the panelists who will be. We will try to be short, but at least to get a few reactions from the day. So, could the panelists join the stage, please? Oh, nice. And Mathieu, where is Mathieu? Here. And Raphael? Is Raphael around? Yes, okay. So, our last session will be to listen a bit to a number of recommendations that were discussed during the sessions. I will explain a bit more later, but we have a panel. Pardon? You cannot. Okay. You don't hear me, really? Yes, I don't know. Okay, is it better here? Yeah. It was fine. Okay. So, sorry, I thought it was, you were not listening to me. So I will ask, I think for the panel, you all know Christian already, but could you please introduce yourself, the different panelists, starting with you, Anaïs.
So I'm Anaïs Lot. I work at the French Livestock Institute at the Climate Department based in Paris, and I work on several European projects on carbon farming.
Hello, I'm Julia Grimaud from I4CE, Institute for Climate Economics. We're a French think tank, and we've worked in France on the label bas carbone, and we're also in several European projects on MRV and carbon farming.
Good afternoon, everyone. I'm Mathieu Mal. I work at I work at EEB, the European Environmental Bureau, which is an umbrella organization for environmental civil society organizations based in Brussels. And I'm also part of the Credible Consortium lead work package 2 on policy.
Hello, my name is José Rafael. I'm a full professor at the University of Évora. I'm an entrepreneur. I'm a farmer at the weekends and a good cooker.
Okay, thank you. Myself, for those who were not necessarily here this morning, I'm Daniel Zimmer from Climate Kick, and I will also moderate this panel that I will introduce by saying that you didn't see this, but in the background before the summit, many session organizers have worked on draft recommendations, because we want this summit not to be just a conference where people talk, but also have some concrete recommendations that will, after the summit, have be discussed and refined and be submitted to DG Climat, but in general to the community or the different organizations working on carbon farming. So this, what we are doing now is just to give you a flavor of some of the topics that have been discussed and what type of recommendations or open questions that remain to be addressed, because next year we'll have another summit and we hope to build also on the results of this summit to go further into guiding implementation and supporting policies. So the 3 recommendations that you will hear are just a subset of many recommendations. They are around, I would say, around 20 key topics that emerged from all the recommendations that were prepared. And it's just the beginning, but we picked some that are not only in the sessions that will be presented, but that have come through several sessions, recommendations that were prepared. So you have the floor also. You have also your own views. So a Menti code will be provided to you, if we could have it, so that you can react on the different recommendations. So here is, so I don't know if you see it, 81420576. This is the Menti to get also your reactions. So we start immediately with a first topic that was addressed this afternoon, which was forestry, and some recommendations on how the forestry sector can implement or should implement particularly baseline and non-permanence issues, and what we can learn also from this experience in the forestry domain. Julia, the floor is yours.
Thank you very much, Daniel. And yes, our forestry session, actually the one and only forestry session, aims to try and bring out forest specificities and discuss forest specificities in terms of carbon certification. And actually I have 2 topics that were really pregnant in the discussions that I'd like to bring forward. There's the question of baseline, as you said, and then the question of permanence and temporary credits. So just a few words on baselines. What we basically discuss is that beyond quantification issues, baseline is mainly the key topic. That's the main parameter to avoid overcrediting, and that's where I would say bigger risk comes from, and that where also the parameter on which we had the biggest scandal, especially in terms of forest carbon in the past years. So this is really the key parameter. And then we had, of course, the discussion around specific versus generic baselines. And I cannot present one recommendation because we have diverging views and we will need to bring this discussion forward. But we can maybe agree on some of the elements. One being this vocabulary issue on what people think as specific or generic or standardized. We don't have the same things behind it, and according to the countries, because there was lots of different practices from different countries, we have the same terminology for different realities. So this was one element. And the other one is that we standardized approach had one way to look at it is look at how much local versus harmonized and global approach do you have? Do you have one average number for Europe or for a country, or do you manage to have access to very local data and local specificities in terms of data, but also in terms of practices and forest practices? And another way to look at it was, does the approach and the baseline comes from the project developers that has to provide the data and prove his baseline, or does it comes from the standard? And those 2 elements were kind of mixed. And what we kind of agreed on is that standardized baselines, I'm trying to be quick, so hopefully that's clear enough, but it has the advantage, if it's not provided by the project developer, but quite of being prescriptive within the methodology and within the standards, it can often allow to lower costs and also to avoid bias. You have uncertainty, but you don't have bias, and you have less information asymmetry. But still, you need to be able to rely on the most local data when you have it. And we have seen examples where we have very specific data for each stand and each plot, but it's not the case in every country. So this was a bit what we agreed on, that it's nice if the approach is standardized because you have those advantages, but you still need to rely on the most local data and practices, also common practices. And on the second point, I'm trying to be quick, sorry. Two specificities of forest credits, permanence, which is common to agriculture, but also the long-term horizons that you have. For some practices, it takes decades for trees to grow, and so it's not the same time frame as agriculture practices. And on the permanence topic that we discussed a lot, it was main element was how do we create a market for those non-permanent credits, because it's never going to be permanent. We can turn it any way we want. It's never going to be permanent, but it doesn't mean it doesn't have value. And we discussed the values that those projects can have on biodiversity, on soil conservation, adaptation of forests to climate change, and which cannot be just on the debate on permanent versus non-permanent, and that the terminology we also discuss of temporary credits does not reflect this diversity of values and does not reflect either the duration, because temporary can be 5 years, can be 50 years, and it's not the same thing. And we also discussed that in terms of climate change impact, short terms, in terms of 20, 30, 40 years also has value, not just very long terms at the end of the century, and that this term, the terminology, the communication, the marketing that we have around this temporary credits or for all nature-based credits should be translated, should not be just summed up to temporary versus permanent, and that we should find a terminology and a communication that allows to bring out those values on carbon and on beyond carbon elements.
Thank you, Julia. We have a lot of reactions on the screen. From the panel, do we have Christian or whoever wants to just intervene?
Yeah, I can start us off. I think the comments on baseline are very pertinent, and I don't follow development of the forestry methodology in so much detail. I'm more focused on the agriculture methodology, but I think the issue is really similar there. The trade-offs you have between having a standardized baseline, which allows you to make it more operational, and you don't have to do the on-plot establishing of the baseline, but you do have the trade-offs, and the trade-off is that it's less accurate. And so if I understand your recommendation correctly, it's about finding this balance between making something operational and making it also robust, which is basically the whole MRV challenge, right? And so as I understand your recommendation, it's really bringing it down to the most local level possible to account for the variability that you have between different regions with different practices and so on. So I think that really highlights, not only for forestry, but also for the other carbon farming methodologies, the challenge of establishing a baseline, and also, as far as I'm aware, the views are really diverging on which kind of baseline and how to tackle those issues best. On the permanence issue, I'm very happy that the CRCF does recognize the different levels of permanence, that there is something like a temporary credit. I think that just is a reflection of reality. Biogenic carbon is not permanent, so I think that's good that the policy reflects that. It does, as you also mentioned, it does create a series of questions, and I think a lot of those questions come down to where, in the end, do those credits end up, and how will they be used? I think that's really the key to how there might or might not be demand for those temporary credits.
Maybe just to quickly add one thing, and where I would agree is that temporary credits maybe not a very good term, and it was not our intention to call it like temporary credit, but it's an activity that can be renewed. So what we want to give incentives is that the activity is continued. And I think it's a very fair point, and it's very transparent to say, okay, the certification, the credit is only valid as long as the activity is monitored. And we want to give good incentives that once farmers, foresters are into it, that they will continue. And so, to me, it can be a very permanent credit, because this is what we want, because in the end, we want that everyone takes up these more sustainable activities. It's just that we cannot put all the liability up front. And this is why we found that solution with this renewable credit. But I think this emphasis on that this is non-permanent is a bit misleading.
Thank you, Christian. We have, I don't know, there are so many comments and suggestions, so I read some of them. Changing the term MRV to analysis may reduce farmer registrations. I don't know if it fits with forestry. So a lot on the local versus more homogeneous baseline. There were some questions about what do we do in peatlands that are forested? Is it a specific case that need to be also addressed because of the balance between the emissions due to the water table drawdown induced by forestry and the forestry, the forest growth? Afforestation of deforested areas makes sense, but creating credits for forestry which rejuvenates naturally is an issue. So these are examples. I don't think we have time. The idea is not to cover all these topics, but it's just to give you a flavor of things that will continue to be discussed after the summit and toward also the next summit next year. But I'm conscious of time. I would like to give the floor to our second speaker, who will also address something that has been raised many times, which is the carbon cost or the carbon value enough to facilitate or to create the buy-in from the farmers? So, Raphael, what came out of your session?
I think the session in the morning was really provocative. It was warm, and I hope to be provocative now also. I believe that sometimes there is a confusion between carbon as a product or as a service. So product, you buy a product as you buy an apple in the supermarket. So carbon as a product, the farmers must know how much I can produce per year and what is the value of that product in the market. So if you multiply the production times the value, you will have, and in the social value that the farmer receives for their income, because they have a family, they have children that they want to go to the university, so these business models need to be developed. So when the price is not so high and the production is not so high also, the value of the revenue for the farmer is low. So it's difficult to engage the farmers in doing these carbon farming activities. So if you look to the carbon as a service, it's more complex than even as a product, because as a service you have a lot of other co-benefits, water, soil, and biodiversity issues and things like this. So the things that we believe that could be interesting to see as a recommendation is to look the business models for small farming, big farming, Northern, Central, and Southern Europe, and looking for these business models to see what type of business models we can have on these type of regions and dimensions of farms, and then going back. So why we have to measure everything, why we have to calculate everything, why we have to construct models for everything, if in the end there is no business. So that's the main ideas that we have discussed in this morning. If there is business, we can study the models, we can study the quantification, the verification, the reporting, whatever. But if there is no business, I think the barriers are so high that we will not resolve the problem of the climate for sure.
Thank
3
you.
minutes.
Yeah, and this relates, I think the issue that we already raised this morning is how can we have enough value from carbon farming to also incentivize even smallholder farmers. I think this is one of your recommendations also, is at least on trying to find solutions to pay for the carbon so that even smallholder farmers can engage with carbon farming, yeah. And so there were, I think, quite a number of other ideas that were proposed. Christian this morning said, okay, can we pool them? But we had also discussion, so and in your session also, can we have different sources of funding, for instance, combine different types of credits, have biodiversity, have other ecosystem services that can pay for the carbon, but there are other solutions also that need to be found in order to make this attractive. It's also, of course, pool not necessarily the carbon, but also the monitoring using the tools that were discussed before. Okay, I stop here. Yes?
Let me make a comment. Also, we have to look for competition. For instance, the price that we have nowadays, 30 to 50 euros in Europe and let's say 10 euros internationally, I think it deals with the projects that are the REDD, the red, I don't know, these projects of conservation for Amazonia, etc. So they didn't produce at all anything. What they do is conserving or reducing deforestation. If you want to produce and to construct a project in Europe, for my calculations, for market price, for 40 years project, you need 100 euros or 120 euros per ton to pay this investment. So it's unrealistic. We are competing with credits. They are not credits itself, are conservation credits. They are also important, but I think the society must know what are the difference between these two credits, because they are competing in the same market.
Do we have reactions from the panel? So 100 per ton is also something that is coming from many people in the room. So is it, Christian, is it an order of magnitude that you would...
This is what I understand, what I hear. And it's so true. There were different types of activities, of results. And what our parliament, what our member states wanted with the carbon removal certification is that we really put an emphasis on those activities that bring additional carbon removals. And these are not the cheap ones. And where you can have a big effect, a big return in terms of climate is rewetting of peatlands, agroforestry. And this is what we are looking at. But of course, once we build all this monitoring, reporting, verification system, we should also use it for the soil carbon, for the other activities, and learn how can we very efficiently manage the data also at the farm level and be helpful for all the reporting that we need. But what I also want to say, I think carbon markets, also in the other sectors of the economy, are often only something to support a transformation. There are so many other benefits for a well-managed soil than just the carbon. So what a carbon market is a means for financing, but a carbon credit is never an end in itself.
Indeed, a number of sessions raised this question and say, yeah, in fact, we need to look at the overall benefits. And in fact, there are many other benefits for the farmers also that we don't know yet, but we will learn also. But there is many people are convinced that we need to take these benefits also into account. Mathieu, or?
Yeah, maybe quickly, because we heard in the presentation before, in the methodology presentation, how the fraction of carbon that remains for certification after you account for the uncertainty in the methodology, after you account for the permanence issue and so on. So a fraction remains, and that makes me wonder whether carbon credits is really. I agree that the concept of the carbon credits is not the end goal, but a tool for transformation. But it makes me wonder whether when it comes to, for example, agriculture, whether that is the correct vehicle to place our bets on when it comes to transforming the sector. As we hear, there's also the issues of the level of cost and then the return you need to get for those credits that we currently don't really see the demand at that level. So I wonder, we're very focused on carbon here, and I know it's many people's business here to focus on carbon, but you could wonder in agriculture or maybe the land sector in general whether carbon is not rather the co-benefit and whether what is really worth investing in is not this transformation of the sector that makes a more resilient, more sustainable food system and environment. I think probably that should be the focus of the investments, because the carbon credits also only works for a certain segment of farms, I think. I know there is the option of grouping farmers, and that's often how, many people worry about what about the small-scale farmers, and then we say, okay, we can do group certifications. But still, I keep hearing that for many different types of farmers, whether they're small farmers, I hear concerns from organic farmers, from people in the regenerative agriculture space. They say that doesn't really work for us. A farmer during one of the sessions today said also, I have a mixed farm and I don't find a methodology, a scheme that actually works for certifying what I'm doing on my farm. So I do think that the carbon credit model, it could be a tool for some farms, but I think you only capture certain farms. And then the question is it an issue that you only capture some farms? It's good to do something that works for the large farms. The conventional farms is good if they change their practices, but I do think there should be business models that work for the other types of farms as well, because they very often already have the tougher business case to start with, and they also, of course, need to build resilience and make their activities more sustainable. So I do feel like we're missing out on a large segment of the agriculture sector by focusing only on carbon credits.
Yes, and maybe we could think of carbon credits as a collateral for insurance mechanism that increase the resilience. I don't know. I think some sessions on finance will be looking at new business models also, innovative ones, where carbon credits can be used not only for carbon indeed, but for resilience, or for other investments in the farms. But we'll see what comes out. I noticed one suggestion, which is should we have the same price for maintaining the carbon in soils, or another one for increasing the carbon in soils? Is it something that we could imagine, having different prices depending on where people are? Because also this issue of the pioneers has been raised so many times. How do we reward them correctly? Christian, any idea on this?
Well, I think what we really need to achieve quickly is increasing the removals and reducing the emissions.
Yeah.
So I think this is, and there's the potential for that, and this is where we should be going and where we get the biggest return on the money. But of course, what we are doing with CSCF, we provide the whole data also to show, like with our certificate of compliance, who has already done a brilliant job in having all the carbon stored in the soils. And there's a certain moment where you cannot anymore store carbon in the soil, and this we will show with the certificate of compliance. And that, I think, a lot of the big food companies, brand owners, will be very keen in using that information and presenting it to their consumers. So there will be many different business cases for that. But I think for all of that, we need underlying a credible monitoring, reporting, verification system, and this is what we are working on. And basically, what we are doing with CSCF, we are providing a tool to value nature. It's the value of nature. It's the asset that we will value, and we are not prescribing one specific contract. So what I hope is also that what we are doing here will make it much easier for farmers to get credits, to get financing, and so on. So there's so much more than just the carbon credit that is in this system, and it's a start about delivering all the data that I think that farmers need to get a better deal.
Thank you. We move on now to the third recommendation. They are not yet fully recommendations, you have noticed, but they are work recommendations that will be delivered in more complete form after the summit. Anaïs, you had a session on how to get farmers more knowledgeable and advisors, farmers and advisors more knowledgeable. We heard this morning that this is also a very important issue raised by several sessions. How do we get the farmers and the advisors more knowledgeable about carbon farming, about CRCF? So what is the recommendation you propose?
So yes, the recommendation is basically to structure carbon farming capacity building, and by doing so to cover both practical implementation but also the economic aspects. So really to have a systemic approach of the production systems, and as we are in a carbon farming and certification process, to have also capacity building on the audit, MRV process, and the planning tools. And when I'm talking about planning tools, I'm talking about tools to model the impact of different scenarios on a farm. To do that, we can rely on the EU repository gathering knowledge on carbon farming for farmers and advisors. It's a repository that will be launched in April in the frame of 3 European projects, and there are other repositories that already exist. But these repositories need to be dynamic and regularly updated with the most recent knowledge. They have to be robust, science-based, and also permanent. It means that they have to live for the long term. So we have, again, to have a systemic and context-specific approach, integrating farm-level tools. Also, we are working with farmers and advisors, and we have to use pedagogical tools that are adapted to their jobs as well, and flexible, time-efficient, and modular learnings. And this capacity building has to begin quite early at the educational level by integrating carbon farming into high school and agricultural schools curricula. And finally, to ensure the same accessibility to these trainings to all the farmers and advisors, this training has to be publicly funded or supported through policy frameworks. And when we talk about the economic impact of carbon farming, we also have to take into account the cost for these trainings for the farmers and for the advisors as well.
Thank you very much, Anaïs. Comments from the panel or from even the other panelists? Huh? Who wants to?
I can be very quick. To my knowledge, 7 out of 10 farmers in the EU rely only on practical experience. Right? Practical experience is very good, but I do think that professional education and support and advisory can be a really important aspect as well of doing your job, especially in a context where we're actually hoping that that people will change their agricultural practices. I think a lot of support is needed to make sure that people are equipped with the right knowledge and the right skills. And that, I think, is actually, because I think you suggested that should come from public funding, and I would agree. I think there's already provisions under the CAP to provide farm advisory services, and I think that's a very good use of public funding in the whole blended finance debate, asking what role is there for public funding, where does the private funding come in. Sometimes, I believe Christian mentioned in his presentation this morning, for example, in agroforestry, you could have public funding to establish the initial phase, and then have the carbon credits or carbon certification take care of the prolonged funding. I understand in these kind of proposals, there's always discussions on, are we in double funding gray area or not? Are we paying with public funds and private funds for essentially the same single activity of establishing agroforestry? But this is an issue that you don't have when we, for example, would fund with public funds would fund advisory services. So I think that's a really good use of public funding.
Just a comment. You see farm advising or training farmers to produce nature? I didn't follow your comments, because for farmer advising, we can also, I believe, advise them in order to save inputs, to reduce emissions on the insetting perspective, because farmers also emit. So I think farm advising would be a very important issue, not only helping farmers to produce nature, but helping farmers also to be more efficient at food level in order to reduce their footprint per ton of food produced. And I think, because most of the farmers somehow are alone to taking decisions, and having someone that can help them to talk and to see solutions with experience could be a very good approach in order to fulfill and the objectives that we want to reach.
Christian, any?
I think for a farmer, the farmer takes a whole farm approach. I don't think that a farmer differentiates between emission reductions, removals, or whatever we like to talk here about. For the farmer, a farmer is an entrepreneur and wants to meet the ends and make a good profit. So, and I think a farmer wants to have one guy who can support, advise him, and not like an army of 10 different people. So this must be simple, straightforward. And there must be a whole ecosystem. There must be all of us around, and we need to learn together over the next years how we can do this. But it's not for a farmer to be told by 500 people what they should do.
Just maybe to add that Credible, the project, in fact, was designed also to create this EU community on carbon farming, bring in different stakeholders. So we tried our best also to get farmers to this summit. Next year we'll continue. And so indeed there is a need also to create this community of practice and ensure that there are enough platforms where the knowledge can be shared. Already today I heard in the session so many interesting experiences, so we need to build on all this, and this is what we will do after the summit as well. There are again a lot of other recommendations. We will take account of all these inputs. I would like to also, if we can go to the last slide on the Menti, we wanted to open the floor. If there are people who have, some of you have important recommendations that you would like to present, please raise your hands, and we still have, let's say, 10 minutes. Before we go to drinks and posters, to get some reactions from the floor. Any, or are you all tired? I had maybe while we are waiting for reactions, I'm always struck by the fact that for farmers, adaptation and resilience is a very interesting entry point to the climate issues. So should we also in this training, in this awareness raising, also have a focus, good balance between adaptation and on carbon removers? Is it a way forward, Christian?
Yeah. But I think it needs to be, as I said, the main interest for the farmer is probably that to keep the asset, to keep the value of nature. So, and whatever we do with a carbon market is to provide additional financing to make that transformation. But I think for the farmer, it's an overall thinking. I think every farmer that just changes to more sustainable practices only because there is a carbon credit program, I don't think that this is the good way.
Yes, very much so. Thank you. So we have at least 2 reactions.
Okay.
We hear you.
We hear about business models, market, money coming around, and we are going in a distance from the initial purpose, which was the reduction of greenhouse gas emissions, because this is what we want to do with carbon sequestration. And we have now new political conditions with the Trump election in the United States, and I would like to ask if Europe has a plan, because the globe is a spherical planet and the atmosphere belongs to all these countries, and I think that Europe now is alone in this battle, and I don't know how China is contributing to this carbon market. India, Russia, now United States are following a completely different direction. So how Europe, the European Commission and the European Union understand these new conditions? Because it's nice to talk about carbon market, but at the end we will be alone, and I don't know who is going to pay for that. And what will be the result in terms of reducing the greenhouse gases? Because they will emit whatever they want, and we will reduce, but Europe is just 500,000 people, and the rest of the globe is nearly 10 billion.
Thank you. I think this relates very much also to the agriculture vision and the competitiveness of agriculture in Europe. Christian, or anybody in the panel would like to say something on this?
I would, so okay, I didn't expect this to go into geopolitics, but I would say that if other regions and actors across the globe reduce their ambitions, then I think that's all the more reason for Europe to step up its ambition. And we will have, in the next weeks, maybe month, an update on our pathway as the EU to climate neutrality in 2050 by setting a target for 2040. And then I hope that there will also be a target for the agricultural sector to do its part on that pathway. Hopefully an ambitious target, so that well, the best we can do is doing our part, I guess, as the EU, and trying to convince other global actors to do the same. But at least start with ourselves.
That's probably also why we need good, solid business models, showing also how we can reduce the costs and be efficient in our agriculture, using all the methods and the tools that are under development. We have other reactions. Can you try to be more on the recommendations?
Go ahead. No, go ahead.
Can you introduce yourself?
Thank you very much. Yes, I'm Julian from Secana. We're a startup that does MRV for carbon farming projects. And essentially what we have found is that this is not rocket science. Sometimes I feel like we're treating, or we're hiding a bit behind the complexity that we see. Complexity is part of it, but we think that measurement-based systems can bring us the type of quantification that we need. And at least for the quantification aspect of the methodology, I think if we make it measurement-based, design unbiased, it can be quite straightforward if we just get the uncertainty deduction straight. Yeah. Everything else can fall into place. So I think this is our key recommendation, to try to specify the uncertainty deductions based on the confidence interval, and then everything else based on what type of MRV technology to use, how many samples to take, and so on. That will all fall into place once that's clarified. Thank you.
Thank you, and thank you. This is indeed an interesting recommendation coming from your session. I think it relates also to what Eric Souberan, I don't know if he's still here, said this morning, that they started early, 15 years ago, but they had then maybe a huge uncertainty and big buffers in the way they operated. And so the more we go, the more the methods are precise, the less these buffers need to be. Rick, some comments on the panel on this?
No, very much agree. And I think this also relates to what I said in the morning. So over the next 5 years, we should learn a lot. And But I think with all the digital tools that we have at our disposal, we can have quite a steep learning curve. And again, this information we are not just only doing for carbon credits. This is information every farmer will be very keen to know.
Yes.
Can I make a question? We are somehow discussing the production side of the problem, farmers and carbon farming. What about the buyers part of the equation? Because are they willing to buy at what price? Do you have an idea at the European level what will be the?
But I talked about that also this morning.
Sorry, I missed.
So, of course, you need to work both on supply and demand. And of course, here we are doing certification, which is on the supply side. And then we need to talk about what we have now with the Corporate Sustainability Reporting Directive, with green claims, with a voluntary market. And then, of course, we are doing studies. And I think given the level of change that we want to see, we will also need to look about regulated markets, because we need a much clearer demand signal. We need more planning certainty for our farmers, because some of the, as I said, the practices where we get the biggest return for the climate, agroforestry, rewetting of peatlands, afforestation, and so on, these are big management changes, so farmers will expect a very clear demand signal.
Yes, I'm just I was speaking about the global market. So a CEO from a company standing in Europe can buy outside of Europe. So
no, we are talking about Europe.
Yeah,
but to buy only in Europe? All the companies in Europe have to buy only in Europe?
We have a deal, or we have an objective to make Europe climate neutral in 2050.
Yes, yes, yes.
And this is our North Star.
Okay, but in terms of business, a company can buy outside.
Yes. But what I'm interested in, is to make Europe climate neutral in 2050.
Okay, I'm speaking about business. But for the farmers, for the European farmers, if the companies buy outside, there is no business for the farmers in Europe. That's what I'm trying to...
Yeah, I mean, we've done emission trading systems for the rest of the economy. And we know very much about carbon leakage and how to address that.
Okay, good.
Yeah, these are very important topics.
Do we have final recommendation? No. Okay. So you are exhausted. Oh, there is one. No? No, okay. Too late, sorry. But you are not, you will have opportunities to comment on the recommendations. All the recommendations that have been prepared will be refined after the summit and will be put on the credible website for comments. We want also to get feedback after the summit, and there will be, I don't know, 2 or 3 months for you to comment on the recommendations so that we can take them on board and disseminate these recommendations. I think with this we finish this wrap-up session. I would like to thank all of you for your participation in this wrap-up. Yes.